All right, so this is the beginning of chapter 9. We're doing a little review preview of some basic concepts you're going to be using here. You're going to want to copy these numbers down, but basically these are perfect squares. So 2 times 2 is 4, 8 times 8 is 64, 10 times 10 is 100. These are the perfect squares. We're going to be using these numbers a lot. You're going to want to reference these in a procedure to simplify radicals, which we're getting to here. I'm going to move on. You might want to hit pause and just copy these down. So the product rule with radicals means basically anything under the radical is the same thing as outside the radical, but it's multiplied. So radical 2 times 3 is the same as radical 2 times radical 3. When I say radical, I mean square root. So the square root of 2 times 3 under the radical is the same thing as radical square root of 2 times square root of 3 separately. All right, and then this is just the opposite direction. You can go split them up or put them together. So that's important here because what we have is the square root of 128. Now, that is an exact answer. We're going to simplify it, just like 2/4 is an exact answer, which is the same as 1/2. We want to simplify it, but let me show you what the square root of 128 is on the calculator. It's 11.3137085. This is an approximation. So when you take the square root and turn it into a decimal, unless it's one of these perfect squares, square root of 25 is 5, you are actually approximating. These are not exact numbers. These are approximate answers because you're going to round. So how do we do this? Well, we go back to our list and we look for numbers that go into 128. Now, a lot of people will go and start like here and say, oh, 4 goes into 128 32 times. And that is true. But you don't want to do that because you're going to have to do it again. You want to start at the bigger numbers here and go backwards. So think about where 128 would be. It would be right here. I don't think anybody's going to think that 121 or 100 goes into 128. They're too big. 100 doubled is 200. You might not know this. So you might take your calculator, do 128, divide by 81, and you're going to get a decimal, all right? So this doesn't take long if you're using the calculator, right? You just do this, and you do 81, and you get a decimal. So that's not it. Then you try the next one, 128 divided by 64. Oh, bingo, you get a whole number, 2. And this is how we write it. We rewrite it like so, okay? And technically, you can go right to here if you want. But basically, you're just splitting this up into 2 numbers. You always want to write the perfect square first because that's going to simplify to just 8. And this is 8 times radical 2. And if I take my calculator and put in 8 times the square root or radical 2, look what I get. The exact same number, 11.31, blah, 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 blah. So these two are equivalent. It's just this one is the simplified version. So let's try it. Square root of 75. You look at your list and find out where 75 is. It's right here. You're not going to probably type in divide by 64. You might not even type in 49. But if you work your way backwards, you'll see it's 25 times 3. So I just suggest you write it like this. Immediately just break it up. You don't have to do the extra step. And then this simplifies to just 5. And the radical 3 or square root of 3 stays. That's it. Now notice this one's special. There's a number already outside here that's going to be multiplied by whatever we take out. All right? So 18. We look on the list and we find out that 9 is a perfect square number that goes into it twice. All right? So I'm going to write this -4 again times, what is the square root of 9? It's 3. And then we simplify. The reason I'm suggesting doing this is because the most common mistake is just to say this is the answer when it's not. People forget to multiply by whatever is outside of the radical. So that's going to be -12 times radical 2. All right? Again, I suggest you do this and put a times there, something like that. Now this is going to break up. What number goes into 24? Well, it's going to be 4 and 6. Always write the perfect square first. Okay? This is going to simplify to just simply 2. And then we multiply. 2 times 2 is 4, radical 6. And again, the beauty of this is you can take your calculator and type in 2 times the square root of 24 and see what that is as a decimal. And you can check your answer. Does 4 times the square root of 6 equal the same thing? You can check this on a quiz or test before you even turn it in. You can verify your answer. All right, 6 outside. I'm going to remind myself the 6 is here times whatever I bring out. So 80. This is kind of a tricky one. Maybe something doesn't come right off the top of your head. So 80 is going to be right here. I'm not going to divide by 64 or 49. 36 times 2 is 72. It's going to be a decimal. 25, 50, 75, 100, decimal. Let's try 16. So we take 80 and divide by 16. Use your calculator. Let it help you out. Boom, there it is, 5. So I'm going to write this as the square root of 16 times the square root of 5. This is going to simplify to just 4. And the radical 5 just tags along. I'm going to multiply this, you get 24, radical 5. And again, if you type this in the calculator and type this in the calculator, you will get the exact same decimal. All right, multiplying. We do outside numbers with outside numbers, inside with inside. So these are both inside the radical, so I just get radical 12. Now think about it. This number does not simplify, and neither does this. There's no perfect square that goes into it. But now that we have 12, we do have 4. 4 is a perfect square. 4 goes into 12 3 times. This simplifies to 2 times radical 3. Now here, we're going to do outside times outside and inside times inside. So the first thing I'm going to do is 3 times 4 is 12. And then 6 times 3 is 18. Now, this is just like the problem from the previous page. Okay? This looks no different than 2, 3, and 4. In fact, look, we already had 18. It breaks down to 9 and 2. I'm going to use that here. 9 and 2. But don't forget to bring this 12 down here. Don't lose it. Now, what is the square root of 9? It's 3. This just tags along. And then I just do this. 12 times 3 is 36, radical 2. And once again, if you want to check your work, watch 3, 6, 4, 3. 3 times the square root of 6, come out, times 4 times the square root of 3. It's 50.9. Now what if I do 36 times square root of 2? Look what I get. The exact same answer. You can check your work. So here, outside times outside is 36. Inside times inside is 5 times 20 is 100. Now this one is nice because this is already a perfect square. So I'm just going to have 36 times 10, which is 360. Final answer. So if this ever ends up being a perfect square, which again is on that list right there, we just go right to 10. Simple enough. All right, division. Now there's a tricky thing with radicals. We're not allowed to have radicals in the bottom. Okay, in the denominator. So we have to do something called rationalizing. So if I had this fraction here, I need to get rid of the radical 5. So what I do is I rewrite it and I multiply by radical 5 over itself, which is equal to 1. And anything times 1 is itself. But watch what happens. On the bottom, I get the square root of 25. And on the top, I just get 4 radical 5. And then when I simplify this, I end up with just 5. That will happen every time. Okay? So let's do this practice one. I'm going to put radical 5 over radical 5. Well, that's what I'm doing. I don't know why I got confused. Sorry. We're multiplying by that, which is 1. That's just outlining the steps. Sorry. Got a little sidetracked. All right? But here's what I want you to think about. This is not on your page. We'll talk about this in class a lot. Radical 7 times radical 7 is radical 49, which just equals 7. Square root of 2 times the square root of 2 equals the square root of 4, which is just 2. But look what you can do. You can just go right there. Radical 8 times radical 8 is simply just 8. The radicals disappear. Okay, so 2 over radical 7. I'm going to do this first. Now on the top, I simply have 2 radical 7. That's it. Down the bottom, I have just 7, and I'm already finished. It's that simple. Okay. You can also simplify. So look at this. If I had 2 over 12, I would simplify that to 1 over 6. Well, guess what? I can do that here. Right? I can divide radical 2 into radical 12. Just like you can divide 2 into 12 here. And then the square root of 1 is simply 1 over radical 6. And now I do my rationalizing trick, which is really easy. On the top, I just get radical 6. And on the bottom, I just get regular 6. And that's my answer. If I want to put a 1 here, I can. No need. Okay? Number 3, same thing. Multiply by radical 6 over radical 6. Real easy. 3 times radical 6 is literally just 3 times radical 6. And this ends up being 6. But wait, I'm not done. This is a fraction that can be reduced to 1/2. And the radical 6 just stays there. We'll be doing plenty of these in class to practice, so don't worry about it. All right, I'm going to simplify first. Always see if you can simplify. 3 goes into 48 16 times. So does radical 3. So that's square root of 1 over the square root of 16. And guess what? I'm not going to have any rationalizing because the square root of 1 is simply 1 and the square root of 16 is simply 4. I'm done with very little work. All right, this is square root of 5 over the square root of 9. But don't waste your time rationalizing because guess what? The square root of 9 is simply just 3. I have no other work to do. All right. Now in this one, you might be tempted to say, hey, can I divide the 6 into 12? No, because the 12 is an outside number, the 6 is an inside number. So on this one, I do have to rationalize. On the top, I simply get 12 radical 6. On the bottom, I get 6. But remember, that reduces. 6 goes into 12 2 times. Radical 6 tags along. Now, 6 does not go into 15, but let's think about this. If I just had 6 over 15, I would divide by 3 and divide by 3, which would give me 2 over 5. But watch this trick. Radical 6 over radical 15 divided by radical 3 over radical 3 gives me radical 2 over radical 5. Now, I don't have to do this. I could rationalize by multiplying by radical 15. It just ends up being bigger numbers. So whenever you can, just reduce. So I'm going to do that now. I'm going to rationalize radical 5 over radical 5. What does that give me on the top? That gives me square root of 2 times square root of 5 is the square root of 10. And then 5 times 5, boom. The radical cancels. All right? I could have done 15, rationalized radical 15. I would have just gotten bigger numbers, and it would have ended up simplifying down to this anyway. So it actually makes my life easier. All right, number 5. Only thing I can do here is rationalize. Okay? Now remember, Outside number and outside number. Those are going to stay right now. So on the top, I have 5 square root of 10. On the bottom, I have 2 times 10. Because those cancel the radical, but this means multiplication, so I have to keep it multiplication. So that gives me 5 radical 10 over 20. And 5 goes into 24 times. 5 over 20 is 1/4. And the radical 10 stays up top. That's it. We'll do a lot of these in class for practice.